First, we are going to talk about the steps of neurotransmission. In step 1, the neuron is at rest. In step 2, the action potential travels down the axon, which is covered with myelin sheath, towards the presynaptic neuron. Once it hits the end of the axon, calcium gates open, allowing calcium to enter the cell. Step 3, the synaptic vesicles that house neurotransmitters travel down the cell membrane that are located at the end of the axon from the synaptic knob. The synaptic vesicles bind to the cell membrane and release the neurotransmitters into the synaptic cleft. The neurotransmitter is in the synaptic cleft and binds to the receptor on the postsynaptic neuron for the message to be decoded. In step 5, an action potential passes along the postsynaptic neuron away from the synapse. Step 6, the transporter proteins move the neurotransmitter back into the presynaptic neuron. The last step is step 7. Neurotransmitters are released from the receptors and are received by the dendrites on the following motor neuron, which picks up the electrical nerve impulse and sends the impulse to the cell body, also known as the soma.
Next, we will talk about the steps of neural impulse conduction. Step 1. The neuron is polarized and inactive. The body is at its resting potential and all of the sodium and potassium gated channels are closed, but leakage channels are open to maintain the resting membrane potential. Step 2. When the threshold stimulus is reached, sodium has moved in to change it from negative 70 MV to negative 55 MV. This causes more sodium channels to open, causing the action potential. Step 3. Sodium keeps moving in, causing depolarization. This is where depolarizing local currents cause sodium channels to open and sodium rushes into the cell. At the absolute threshold, positive feedback allows all the sodium channels to open. Step 4. Repolarization occurs, causing the sodium channels inactivation gates to close. Then voltage-gated potassium channels open, allowing potassium to exit the cell. Step 5. The refractory period puts everything on hold and the sodium-potassium pump restores the original ionic positions by putting the sodium on the outside and the K+ on the inside. Step 6. This is the last step and the neuron is back to its original resting potential.